Welcome to Conceptual Cambridge. Today we are going to cover series. So let's begin. So starting with binomial expansion. So first of all, what is the meaning of binomial expansion? Binomial means two terms and we are just going to expand those terms. So for example, you have already learned to expand a plus b square in brackets, which will be equal to a square plus 2ab plus b square. But as the power keeps increasing, for example a plus b to the power of 3, it keeps getting harder and harder to expand. So what we are trying to do over here is trying to find an easier method to expand these things. So as you can see here, I've written down all of these to the power of 4 till the power of 4. So now let's try to find a pattern. First of all, we can discuss something called the Pascal's triangle, which is basically a pattern that the coefficients will form. So let's start from the coefficients. So the coefficient for 0 is 1, then for the power of 1 it is 1 and 1, then moving down it becomes 1, 2, 1, which will be like 2 will be in the middle, 1, 2, 1, yeah, something like this. And then it will be 1, 3, 3, 1, 1, 3, 3, 1, and then 1, 4, 6, 4, 1, 1, 4, 6, 4, 1. So as you can see, there is a pattern. All of the numbers start and end with 1. First of all, this is the very basic pattern. Let me just, yes, okay. So first of all, this is one of the patterns, and now let's discuss the second pattern. So what is happening over here? So first of all, it all starts from 1. This is when the power n is equal to 0. We are considering the power as n. So n is 0, and the second one occurs when n is equal to 1. The third one occurs when n is equal to 2. So as you can see over here, the terms are 1 greater than the powers. First of all, this is one of the things. So for example, n is 0 and we have one term, n is 1 and we have two terms. Now let's try and discuss the second pattern. The second pattern, let me just draw it a little bit better. 1, 2, 1, 1, 3, 3, 1, something like this. Now let me erase, and 1, 4, 6, 4, 1. So 1, 4, 6, 4, 1. And also 1, 1. Yes. Okay, so now let's discuss the pattern. As you can see, the middle number of every next term is basically the whenever we add the first two terms we will get that second term. So for example, 1 plus 1 is equal to 2. Now if I was to choose this 3, then I can also do this, which is 1 plus 2, and the same with the other 3. And now we can just keep on doing this. So as you can see over here, 4 will be due to this, 6 will be due to the 3 and 3, same with the other 4. This is one of the pattern, and if we keep following this pattern, we should be able to deduce what it will be when the n is 5. So let's try and figure that out. So first of all, we know it is going to start with 1 and end with 1. This is one of the basic things. And now the second one term will be the addition of this, which is basically 5. Now 4 and 6, which is 10. Now 6 and 4 again, which is 10. Now 4 and 1 again, which is 5. So these are going to be the coefficients when the power is 5. And now let's discuss the other pattern. So for example, let me erase. As you can see over here, first of all, the power of the first term starts with 4 and then it becomes 3, 2, 1, and 0. It keeps on decreasing. And for the second term, the power starts from 0 and keeps on increasing. As you can see, 0, 1, 2, 3, and 4. So this is the other pattern. Using these patterns, we can deduce what when the power is 5, what we are going to get. We are going to get 1, so this is going to be a to the power of 5 plus 5 into a4 b1 plus 10 into a cube b square plus 10 a square b cube plus 5 a b to the power of 4, and now we have plus b to the power of 5. So this is what we are going to get when the power is 5. This is one method to find out. This is called the Pascal's triangle method, but I'm going to discuss a better method which will be given to you in the formula sheet. So let's discuss that. So this is the easier method that we are going to discuss over here. As you can see, this is what is given to you in the formula sheet. So as you can see, a plus b to the power of n, and alright, so what is this when n and 1? What is this n and 1 in brackets? We are going to discuss that firstly. So what this means is that you will go on your calculator and you will find an option like this, NCR. Let me open the calculator and show you. So now as you can see, I've opened my calculator. So you can see in the place of division there is something written called NCR. So that is what we are going to use as we discussed before. So let's say the power was 5. So what is the first term going to be? The first term is always 1 and the last term is always 1 as we discussed before. So let's see, 5 C, and at first term the it is going to be 0. It is not going to be 1, as you can see from the formula above, which is already given. As you can see, it gives you 1, and at the last place, let's discuss that too, which is 5c5. At the last plate it is also 1. So now let's see, find the coefficient of x in the expansion of 1 over x plus 3x square to the power of 5. So to do this, first of all, let me write it all out. Let me close the calculator. Now let me write it. Let me erase. Now let me write it. Alright, so 1 over x a to the power of n has 5c1, 5c1, 1 over x, and minus 1 means 5 minus 1, which means this will be 4 now, and now it will start for b 3x square. Now 5c2, 1 over x to the power of 3, and 3x square squared. Now let's see if we can find the coefficient of x by using this. If so we are going to ignore the nc1, we are going to ignore 5c1 and 5c2 for now. Let's see in what we can get coefficient of x. If you see in the first term we have 1 over x to the power of 5. This means that I will have the term x minus 5, which is not x. So now let's see the second one. If I use this, this will give me 4 minus 2, which gives basically something like this, 1 over x and x square, 1 over x to the power of 4 and x square. If you try to cancel out the powers, this will give me x minus 2, which is also not x, or basically 1 over x squared. This is what it is. And now let's see the third term. So what this is, 1 over x cube and 3x squared, which means that we have x to the power of 4. Now this will give you the coefficient of x. Why? Because when you try to cancel out the power, this gives you 1. This gives you x basically. So we are, from this we can deduce that we are going to use the third term for this. We don't need to move any further from this. However, you can, but we don't have to. So now let's go back to our calculator and find out what is 5c2. Let's see. So as you can see, 5c2 means 10. So we are going to use this now. So we have 10 into 1 over x cube and 3x squared. Let me just write it all out. 3x squared means that 3 will also be squared, which means we have 9x to the power of 4. And now when I try to multiply all of this, this will give me 90x. So the coefficient of x will be 90. Our answer is supposed to be this. This is how we are going to apply the formula.